Are you getting ready for the ASVAB Mechanical Comprehension subtest? If you want to strengthen your understanding of the mechanical and physical principles tested on the exam, you're in the right place. Hi, I'm Aisha and I'm a test prep expert with Study.com. Let's jump into some practice questions so you can test your knowledge and build confidence. Then stick around until the end where I'll share some important information about the ASVAB Mechanical Comprehension subtest and a few tips to help you prepare more effectively. Let's get started.
A simplified piping and instrumentation diagram, P and ID, for a compressed air system is shown below. Compared to the pressure at gauge P1, the pressure at gauge P2 is A, at atmospheric pressure, B, higher than the pressure at gauge P1, C, lower than the pressure at gauge P1, or D, equal to the pressure at gauge P1. Alright, so let's break this down. Gauge P1 is located on the inlet side of the air compressor where air is entering the system. Gauge P2 is located on the outlet side after the compressor has increased the air pressure. Since the purpose of an air compressor is to compress air and raise its pressure, the pressure measured at P2 will be higher than the pressure at P1. Knowing that would give us answer B. Let's take a look at the other answer choices. Answer A says the pressure is at atmospheric pressure or 0 psig. This is incorrect because P2 measures compressed air after it leaves the compressor, so its pressure is well above atmospheric pressure. Answer C says the pressure at P2 is lower than at P1. That would be true if pressure were being reduced, but the compressor is designed to increase pressure, not decrease it. Answer D says the pressures are equal. Since the compressor raises the pressure of the air as it moves through the system, the two gauges cannot reach the same pressure during normal operation. So the correct answer is B, higher than the pressure at gauge P1.
All right, let's take a look at this question. It says, an internal combustion engine involves turning blank energy into blank energy. Is it A, mechanical and chemical, B, electrical and mechanical, C, chemical and mechanical, or D, chemical and electrical? Let's start by defining the different types of energy that are mentioned in the answer. So let's start with mechanical, and I'll just make that M. And when I think of mechanical energy, I would say to think of motion. When I think of chemical energy is energy that's stored in substances. So think of gasoline, diesel, fuel. So I'll say to think of gasoline energy stored. And let's go with electrical energy. Electrical energy is energy that's carried by moving electrical charges. I usually would think of electricity. Also, you can also think of like power. So now let's think about what happens inside an internal combustion engine. When gasoline mixes with air and is ignited by a spark plug, the fuel burns. This combustion releases the chemical energy stored in the fuel as heating and expanding gases. Those expanding gases push the pistons downward, causing the crankshaft to rotate. The rotational motion is mechanical energy, which is used to move the vehicle. So the first part is fuel. The second part is moving the vehicle. So fuel, we said that was gas, chemical energy, and then moving the vehicle, we said that was mechanical. So this would start out as chemical and convert into mechanical energy, making C the correct choice. Let's take a look at the other answer choices. Answer A says mechanical energy into chemical energy. This reverses the process, so we know that that's not it. Answer B says electrical energy into mechanical energy. And while electricity does play a role in starting the engine, it's not the engine's primary energy source. Answer D says chemical energy into electrical energy. And while the vehicle does generate electricity after it's running, that's the job of the alternator, which is driven by the spinning engine. The internal combustion engine itself is primarily converting chemical energy into mechanical energy, so the correct answer is C, chemical energy into mechanical energy. The piston and cylinder in an automobile's internal combustion engine, A, convert the battery's electrical energy to mechanical work, B, convert the thermal energy of combustion to mechanical work, C, lower the temperature of the coolant system, or D, convert the battery's electrical energy to chemical energy. Inside the engine cylinder, burning fuel creates hot, expanding gases. Those gases push the piston downward, and that movement is converted into mechanical work that powers the engine. So, with that knowledge, we can determine that the answer is B. Convert thermal energy of combustion to mechanical work. Let's take a look at the other answer choices. Answer A says the piston converts the battery's electrical energy into mechanical work. That's actually the job of the starter motor during engine startup, not the piston. Answer C says the piston lowers the temperature of the coolant system. The cooling system removes excess heat from the engine, but that's not the function of the piston and the cylinder. Answer D says the piston converts electrical energy into chemical energy. This process doesn't occur in an internal combustion engine. So the correct answer is B. Convert the thermal energy of combustion to mechanical work. Fuses, compared to circuit breakers, A, cost more than the circuit breaker, B, never melt, C, can only be used once, or D, cannot help prevent fires. Let's go through all of our answer choices. Answer A says fuses cost more than circuit breakers. In general, the opposite is true. Fuses are usually less expensive. So we know that it's not A. Answer B says fuses never melt. Melting is exactly how a fuse protects an electrical circuit from excessive current. So we know that B is not the answer. Answer C says can only be used once. A fuse contains a thin metal strip that melts when too much current flows through it. Once that strip melts, the fuse no longer works and must be replaced, meaning that it could only be used once. Let's keep C as an option. Let's take a look at answer D. Answer D says fuses cannot help prevent fires. This is incorrect because both fuses and circuit breakers are designed to interrupt excessive current, reducing the risk of overheating and electrical fires. So we know that the answer is not D. So the correct answer is C, can only be used once. Now that you've worked through these practice questions, let's take a moment to review what the ASVAB Mechanical Comprehension Subtest is all about. This section measures your understanding of basic mechanical and physical principles and your ability to apply them to real-world situations. The questions often cover topics such as simple machines, force and motions, gears, pulleys, levers, fluids, and other fundamental mechanical concepts. In this practice set, we focused on understanding how these principles work and applying them to solve common mechanical comprehension questions. As you continue preparing, remember to carefully examine diagrams, identify the mechanical principles involved before choosing an answer, and think through how forces, motion, and machine components interact. Taking your time to analyze each question can help you avoid common mistakes and improve your accuracy. Every practice question you work through helps build your confidence and strengthen the knowledge you'll need on test day. If you'd like more support, Study.com's ASVAB Prep course includes full-length practice exams, hundreds of realistic practice questions, detailed answer explanations, and short video lessons designed to keep your studying focused and efficient. If you have any questions, feel free to leave them in the comments below. Thanks for watching, and best of luck with your ASVAB preparation.